All right, today we're going to be covering 1.5, division of segments and angles. Our learning target today is 1.5. I can bisect and trisect an angle. So, some key words here, bisect and trisect. These are important vocabulary words for us today. Bi means two, of course, like bicycle, and tri means three, like a tricycle. And then these sects here just mean sections. So we're going to be splitting angles into 2 sections and 3 sections. We're also going to be dealing with segments doing the same exact thing, where we're going to be splitting them in 2 as well, and also 3. So let's get started. First off, our definition of a bisection is a point, segment, ray, or line, so it can be any 4 of these 4 things, that divides a segment into 2 congruent segments, bisects that segment. So anytime that I have a segment here, and I have a point, it doesn't necessarily need to be a point. It could be a segment, it could be a ray, or it could be a line. It can be any of these things. Anytime that we have this occurring, and it is right in the center of our segment here, and it creates 2 equal segments on either side. So these 2 segments are equal, from A to this midpoint and B to this midpoint. Well, we call that a bisection. So this green line here is bisecting this segment. Now, a bisection will always go through the midpoint of a segment. It's very important for us to know as we continue through. So, for these 2 examples here, we have this ray with point X on it and this line with point Y on it. So it's very important that we realize that only segments have midpoints. Rays cannot have midpoints because this arrow here. So anytime that you see an arrow, that's telling us that it's going to continue on forever. It's going to go off my screen, through my wall, and around the earth. It's going to keep going forever. So what that means is if it's going on forever, if it never ends, then there's no set distance. And if there's no set distance, then there cannot be a middle point because I can't find the middle. It continues forever. It never stops. Same thing with a line. It goes in both directions forever, so it will never stop either. So the arrow means that it continues forever. So therefore, I can never say that this segment is congruent to that ray. Because again, the segment has a finite length, it ends, meanwhile the ray will continue forever. And with a line, I can't say that this point is in the middle of this line here, point Y, because Y goes in both directions forever. That line continues forever in both those directions. Now you may be saying, well, if it continues in infinite directions forever, couldn't Y still be in the middle of that infinite amount in either way? Well, since there are different sizes of infinity, we cannot actually state that for certain. So therefore, there's no way for us to prove that Y is actually in the middle of a line. So there is no midpoint on a line either, because again, it continues forever. So only segments will have midpoints as a result, no matter what. And the way that we can determine where the midpoint is it's in the middle of our segment. So there should always only be one midpoint within a segment. Now, through that one midpoint, I can have a lot of different types of bisectors going through it. Like I said, we can have a point as a bisector, we can have a ray, we can have another line going through it in a different direction. I can even have another segment bisecting this, and I can say the segment's a little bit longer on one side than the other. It doesn't need to be perfect or anything. So, how many bisectors could we actually have here? Well, there's an infinite amount of bisectors that we can choose from. It's not just one, it can be any. So all these different types of bisectors, no matter which type of bisector you deal with, these bisectors will always go through the one midpoint of the segment. So that makes it really easy for us to find these things because we know that they always have to go through the midpoint. Now, here's our first example. If XY bisects AC at point B, what conclusions can we draw? So they're saying that XY is doing the cutting. XY is cutting segment AC into 2 pieces. So if that's the case, there's a couple things that we can conclude from this. First off, point B is the midpoint of segment AC. Point B must be right in the middle because again, XY is bisecting. It's cutting it in 2. And that's by definition of a midpoint and also definition of bisection. If you're bisecting something, you're cutting it into 2 equal pieces. If that's the case, then we can also conclude that segment AB is congruent to segment BC. That must also be true because if it is being cut right in the middle, then it should be equal on both sides. Now, could I say that segment XB, so this segment here, is congruent to segment BY? Well, no, we couldn't actually say this. The reasoning behind that is because XY is bisecting a segment, not AC. So I have no clue if AC is actually being a bisection. Let me rephrase that. I don't know if AC is actually bisecting segment XY. So if they told me that AC bisects XY at point B, then I can absolutely say this. However, since they are not giving us that information, we say that they are not congruent, or we would need more information at least in order to show that they're congruent. But we could not just, from the information given to us, we could not say that this is a true statement. All right, let's continue on. Example 2. If D is the midpoint of FE, what conclusions can we draw? So I know D is the midpoint of segment FE. Well, if that's the case, I can say that point D is the midpoint, or point D is the bisector of segment FE. But I could also say the same thing with segment GD. So segment GD is the bisector of segment FE. We could also say that. Also, if D is the midpoint, then that should mean that FD is congruent to DE. So again, GD is the bisector of FE, and also FD is congruent to DE because it is the midpoint, and we're bisecting. That's the definition of a bisector. All right, example 3. If segment OK is congruent to segment KP, what conclusions can we draw? Well, the first thing is that point K is the midpoint. So K is a midpoint. That's the first thing that we can definitely tell from this picture. The other conclusion that we can draw is that line JM is the bisector. So if these two segments are congruent to each other, OK and KP, and line JM is going straight through the middle of them, through that midpoint, then we can say that JM is the bisector, line JM. And it's bisecting at point K, which we know is the midpoint. Now, that's very important for us as well, so keep that in mind. We're crossing through the midpoint. Meanwhile, the thing that's doing the crossing, the intersection, that's our bisector. So, could I say that K is the midpoint of line JM? Well, no. Think about it. Point K is bisecting line JM? No, we can't bisect lines, so we could not actually say that for a fact. We can only say that K is bisecting line OP, line segment OP. Now, again, if you used a different line rather than JM, if you called it JK or KM, or line MJ or MK, those are all fine lines as well. They're the same exact line. It won't really change anything. Just know that JM and KM, those are the same things. All right, next up, we're going to talk about trisections. So trisections are 2 points, segments, rays, or lines, so same type of definition as a bisector, except this time we're dealing with 2 of them, so 2 points that divide a segment into 3 congruent segments. We say that these trisect the segment. The 2 points at which the segment is divided are called trisection points of the segment. So if I have a segment here, and I have 2 points that lie on the segment that are equidistant away from either end, then we say that these points are trisection points. So these are our trisection points. And with those trisection points, it's splitting our segment into 3 equal pieces. And that's all a trisection is. It's the same concept as a bisection, except this time we're not crossing through the midpoint, we're crossing through trisection points. So that's the only difference. Now, trisection, it's broken into 3 pieces, so I take my whole distance and I divide it by 3 to find out where these trisection points can be found. So that's how we can determine where our trisection points are. So, again, only segments can have trisection points. Rays and lines can't have trisection points. The exact same reason why we can't have midpoints of lines or rays. It's the same thing. These lines and rays carry on forever, and we can't do that. Not with midpoints, at least, or trisection points. So, with this picture here, we have segment AR is congruent to segment RS, which is congruent to segment SC. What conclusions can we draw from this? Well, first off, we know that points R and S are our trisection points because it is breaking it into 3 congruent parts. We also know, if that's the case, if these are our trisection points, that these 2 points trisect segment AC. So these are the points that are doing the trisection, because again, we're not dealing with lines or rays or anything with this one, or segments, we're dealing with points. So these trisection points are also the things that are trisecting our segment. So if points F and E are trisection points of segment DG, so again, these are trisection points, what conclusions can we draw? Well, first off, if they're trisection points, then I know that DE is congruent to EF, which is congruent to FG. Right off the bat, if it's trisection, I know that's going to be broken into 3 congruent pieces. The other thing that we can conclude from this is which things in this picture are doing the trisection. Which things are doing the trisection? Well, the points E and F are. So we can say points E and F trisect segment DG. And again, we can also say segment DE is congruent to segment EF, which is congruent to segment FG, and that's due to the definition of a trisection. So those are the conclusions that we can come to with example 2. All right, now we're going to talk about angle bisectors. So we talked about segment bisectors and segment trisectors. Now we're going to talk about angle bisectors. And I'm guessing you can assume that we're going to be moving towards angle trisectors after that, and you're absolutely right. So again, this is the main topic that we're going to be covering today, angle trisections and angle bisections. Those are on the learning target, so keep that in mind. An angle, like a segment, can be bisected. However, it's very important that we know whenever we're bisecting or trisecting an angle, the thing that is doing the trisection must be a ray. It cannot be any other figure, it must be a ray. So a ray that divides an angle into 2 congruent angles, so again, it's taking a full angle, and we're cutting it into 2 congruent angles. We say that that the full angle with this ray going through, that is called a bisection of an angle. It's an angle bisector. So we call this ray that's going through the dividing ray. So this is known as the dividing ray. And it's also known more commonly as the bisector of an angle. So if I'm asking for a bisector, I'm talking about this ray here. And I'm just going to go ahead and draw my arrows on the end to make sure that I'm showing proper notation. So this is our dividing ray and also the angle bisector of this large angle here. Now, here's a quick little picture of it, make it a little bit nicer for you as well. If angle ABD is congruent to angle DBC, then ray BD, and again, that's very important that we start at B and we move towards D, because if I started at D and I move towards B, it would be going into our vertex, right? So we need to be cutting through our angle. So it's starting at our vertex, moving through our angle. So BD, ray BD, is the bisector of angle ABC. So what's another name that we can call ray BD? Well, we can call that our dividing ray. And we can also call it our bisector. So don't forget, those are the 2 names for this ray that is cutting our angle into 2 equal angles. All right, angle trisectors. Exact same thing, except this time it's going to be 2 rays that cut it into 3 equal angles. So again, that's all that changes. 2 rays now, 3 equal parts. Now, again, we say that this is a trisection. We're trisecting an angle. So if I say we need to trisect this angle, this is what we do. The 2 dividing rays, so if we have an angle, and we have 2 rays here that are cutting this angle into 3 equal parts. So we call these 2 rays dividing rays, once again, and we also call them trisectors. So there's going to be 2 trisectors or 2 dividing rays when we're trisecting an angle. Same exact type of concept as bisections. So if you have bisections, same thing occurs with trisections. except now we add an extra ray, and now it's 3 equal parts. That's it. So, again, a nice little picture for us. If angle ABC is congruent to angle CBD, which is congruent to angle DBE, then ray B through C and ray B through D trisect angle ABE, the large angle. So that's all that's occurring here. These dividing rays, these trisectors, are trisecting our angle into 3 equal parts. And again, the reason that I call we don't need to focus on points or angles, not angles, we need to focus on angles, on points or lines or segments right now with angles, is because what are angles made of? Well, they're made of 2 rays that share a common endpoint. So therefore, if I'm going to be creating more equal angles, I can't make angles without rays. And that's why these must be rays. They can't be any other type of figure. They can't be a segment or a line or anything like that. It must be a dividing ray. All right, here's a couple problems for us to work on. Problem 1, and feel free to pause at any time if you want to work on it prior to me going through it. Problem 1, the tick mark indicates that RS is congruent to ST. Is point S the midpoint of segment RT? So I went ahead and just drew segment RT up here. And again, the reason that it's a straight line is because the fastest distance between 2 points is a straight line. So segment RT cannot take any detours. It needs to be straight. So is S the midpoint of segment RT? Well, no. They are not collinear points. R, S, and T do not all lie on this purple line. S doesn't lie on this line, so therefore S cannot be the midpoint. However, if S did lie on this line and they were all collinear, it would absolutely be the midpoint because it's separating this into 2 equal parts. The problem is that it's not collinear. Collinearity still needs to occur for a point to be considered a midpoint. Problem number 2. If ray BD bisects angle ABC, does ray DB bisect angle ADC? So they're asking, is this ray here, BD, if that's occurring and it's bisecting this angle here, this yellow angle, it's cutting it perfectly into 2 equal parts. If this is true, does that mean that this ray, this blue ray, cuts this red angle into 2 different parts? Well, no, not necessarily, not always. We would need more information on this one, and here's why. What if I'm going to exaggerate my figure a little bit. I'm going to say that this top end is a lot further out just to show the exaggeration. And I have this diagonal going through. So we're assuming that these are the same figures. I'm just exaggerating this top. I'm making it very large so that we can see the exaggeration of the angle. And even if it was just by a tiny bit different, then this exaggeration is occurring. So, as we can see, these 2 angles can be congruent. However, when I look at these other 2 angles down below, this red angle and I'll make it green, this green angle. Well, obviously, this red angle and this green angle are not congruent to each other. One almost looks like it's close to obtuse or a right angle, and then the other is definitely an acute angle. So, again, we need more information. We need to know if these side lengths are the same length. We would need to know if these 2 angles are being bisected as well. But we just can't tell from the information that they actually give us in this problem. So, problem 3. If points B and C trisect segment AD, do rays EB and EC trisect angle AED? So go ahead and pause this if you'd like and try and answer it. Our answer for this one is no. So here's the picture that they're going for. They're saying if these segments are all congruent, AB, BC, and CD are all congruent, does that mean that these 3 angles are congruent? And the answer is no. Well, we'd need more information. But just for this problem itself, we're not sure. If I have a segment trisection occurring, that does not mean that an angle trisection is occurring. One does not cause the other to occur. And in fact, the only way that this would actually work is dependent upon the position of point E. So if point E is actually lining up, then there's a very good chance that this would be an angle trisection. However, I don't know where E is positioned. E could be much higher up, and again, this is an exaggeration of the picture, because if I make an extreme exaggeration, then it just shows where the error could occur more. So if E is higher up, then of course these angles aren't going to be congruent. Or if it's a lot lower to the ground, it also will not be congruent. It's totally dependent on where point E is. So we would need more information for this. And again, a segment trisection does not mean that an angle trisection is going to happen. They're totally different problems, two different things occurring that are happening. So one does not cause the other. One does not mean that the other is happening as well either. Very important. All right, here's problem number 7. You can pause the video if you'd like. Try it out on your own, and then we'll go through it. So it says segment EH is divided by points F and G in the ratio of 5:3:2, respectively, from left to right. So 5:3:2. If the length of E to H is 30, find segment FG's length and name the midpoint of segment EH. So, to get started on this, we have a ratio. And when we have a ratio and they give us our segment and they say it's going from left to right, I can go ahead and fill in these numbers right above. So I'm going to say EF is 5, FG is 3, and GH is 2. That's what I'm going to start off with. Now, we also know the whole segment length is 30. They tell us EH is equal to 30. So the whole thing from E all the way to H is 30. We're not separating it yet or anything like that. The whole thing's 30 right now. Now, if we're given a ratio, we're just going to give each of these a variable. So it's going to turn into 5x, 3x, and 2x. And we're going to bring that over here as well. 5x, 3x, and 2x. And we know that these, I guess I could say, this expression, 5x, 3x, and 2x, this whole length is equal to 30 units. So let's go ahead and use angle addition postulate. EF plus FG plus GH equals the whole thing, EH. Or we can say 5x plus 3x plus 2x equals 30. Again, this is just the segment addition postulate that we're doing, nothing else. So from here, if I combine all my like terms, all my x variables together, we get 10x equals 30. And solving for x, we find out that x equals 3. Now, that's not what they're asking for. They're not saying solve for x. They're saying find the length of FG. So we're going to go ahead and take this x equals 3, and let's plug it in for segment FG. Well, if FG is 3x, FG's length should be 3 times 3, or 9 units. Lastly, we need to find the midpoint of EH. So the midpoint is the middle point. If the whole thing is 30, where's the middle at? It should be halfway to it. So halfway to 30 is 15. So our midpoint should be where our segment hits 15. So we're going to go ahead and take this 3 again. We're going to plug it back in for each of these x's to find out where we would hit 15. So from here, we find out that if I plug in 3 for x for EF, we get 5 times 3, which is 15. Point F is 15 away from one of our endpoints, which means that's right in the middle. Point F must be our midpoint. And that is the answer to this question, point F. All right. Lastly, given this angle here, angle JKM, and then, of course, we have 2 different angles inside of JKM as well. We know ray KO bisects angle JKM. So we're being bisected right here, cut in 2 perfect pieces. We know angle JKM, the large angle here, this red angle, this whole thing's measurement is 41 degrees, 37 minutes. What we want to find is the measure of angle OKM. So if I know the whole thing is 41 degrees, 37 minutes, and it's being bisected, and we want to find one of those bisections, we want to find OKM, we want to find this angle measurement. Well, what if I take this angle measurement, the whole thing, and I cut it in half? I divide by 2. Well, that will find me one of our smaller angles. So let's do that. The angle OKM is equal to 1/2 of angle JKM, the whole thing. Well, JKM is 41 degrees and 37 minutes. That's given to us. So what I'm going to do is I'm going to go ahead and take away one of my minutes, and I'm going to turn it into seconds, because I know that if I take half right now when it's at 37, it's going to give me a decimal. You may be like, well, hold on, it's going to give you a decimal over here as well. You're absolutely right, it will. However, we'll be able to convert this in a little bit. You may be like, well, can't we convert that as well? Yes, but I don't want to throw too much at you right now. So I take away one of my minutes, and that will give me an additional 60 seconds. So that's where the 60 seconds comes in. So if I take half of 41, we get 20.5. Half of 36 is 18, and half of 60 is 30. So this is where we're at. The measure of OKM is equal to 20.5 degrees, 18 minutes, and 30 seconds. However, if I'm in degrees, minutes, and seconds, it doesn't make sense for me to have a decimal here. Because again, the decimal is the minutes and seconds. That's what we're converting into. So if I know that 1 degree equals 60 minutes, how much does half a degree equal? Well, half a degree would equal 30 minutes. If 1 is 60, half would be 30. So therefore, I'm going to take 30 minutes from this 0.5, and this 0.5 is going to disappear. And I'm going to add 30 minutes on top of that 18. So our final answer is actually 20 degrees, 48 minutes, and 30 seconds. And that is our final answer. So we have now covered learning target 1.5. I can bisect and trisect an angle. Be sure that you guys are ready for this. You will see more problems like this in the near future as well. Thank you guys for watching. If you have any questions, please let me know. Leave it in the comments. Other than that, I'll see you guys soon. Take care.